Hello students. So today we are still in chapter 8. We are now looking at the section on costs. So we'll divide costs up into a number of different categories. So one way of dividing them up is you have fixed costs and you have variable costs. The fixed costs are the same no matter how much or how little you produce. They're fixed. That's why I call them fixed costs. The other kind of cost is a variable cost. Variable cost varies depending upon how much you make, hence the name variable cost. So if you produce more stuff, your variable cost will be higher. So you have to pay your workers, and that's going to be a variable cost. The more stuff you produce, the more workers you have to hire or have them work longer hours, so you got to pay them more money either way. So that expense goes up the more you produce. On the other hand, if you're paying rent on your storefront in a mall, that's a fixed cost. You still got to pay rent to the landlord whether you produce 0 units or whether you produce 100 units. So that cost is fixed. So TVC is going to be total variable cost. This will be the first of many abbreviations you'll see in this chapter. Total fixed cost will be TFC. Now there's also the average fixed cost, AFC, and average variable cost, AVC. So to get the average fixed cost, you just divide the total fixed cost by quantity. So average fixed cost should always go down as you produce more. Why is that? Well, the fixed cost is always going to be the same amount, the total fixed cost up here. Recall we said the fixed costs do not depend on how much you make. They're always going to be constant. So as you increase Q, you're dividing the same number by something that's getting bigger and bigger. If you divide by a bigger number, that makes things smaller. So AFC should always go down as Q goes up. I can't guarantee the same thing for average variable cost. That might go up or go down depending upon the firm. So it's always calculated by total variable cost divided by Q. The total cost is going to be just your total fixed cost plus your total variable cost. We'll abbreviate that as TC. The average total cost is going to be your cost per unit. So total cost divided by Q. So more abbreviations. And don't worry if you're worried that we're going to have not enough abbreviations in this chapter and you want to learn more abbreviations are coming. There's also the marginal cost. So marginal cost is another very important idea. You'll see marginal cost not just in this course, but in probably all of your other econ classes that you ever take. So the marginal cost is when how much your total costs change when you produce one extra unit. That's an approximation. If you want to see a more exact definition, go ahead and take the next class in the sequence Intermediate Micro. So here's an example so you can see how marginal cost is calculated. Let's say when output 0, your total costs are 200. How is that possible? Shouldn't there be a total cost of 0 when you're making 0 units? Not necessarily. You might still have fixed costs. Recall my earlier example, you still got to pay rent at the mall for your storefront even if you don't produce anything. So you still have total costs even when output is 0 because of your fixed costs. Now if you produce 1 unit, let's say your total costs go up to 500. If total costs are previously 200 and now they're 500, that means they went up by 300. Therefore, your marginal costs are 300. 200 plus 300 equals 500. If you produce a second unit, now your total costs are 900. That's 400 higher than they were before. 500 plus 400 is 900. That means your marginal cost for that second unit is 400. So here's an exercise for you guys. I start out this table here, but I left a lot of blanks for you to fill in. So pause the video here and fill in those blanks. When you think you have the answer, press play and we'll see if you're right. Okay, I'll assume you've given this some thought. Let's work through it. So the fixed costs are going to be the same no matter how much or how little you produce. That's why I said they're fixed. So your fixed costs were 100. When output is 0, that means your fixed costs are still 100 even if you produce 1 and even when you produce 2. So that part of the table is pretty easy. To get your total cost, what you do is you add together your fixed costs and your variable costs. 100 plus 0 is 100, so that's where that number is coming from. 100 plus 20 is 120. 100 plus 50 is 150. So we got the first couple of columns filled in. Now let's go work on the rest. We said that average variable cost AVC was our total variable cost divided by quantity. So here we had a total variable cost of 20. We produced 1 unit. So 20 divided by 1 is 20. So that's where this number is coming from. When we had 2 units, our total variable costs were 50. 50 divided by 2 is 25. So we got the average variable cost column down. Now we can look at average fixed cost. So we just take total fixed cost and we divide that by quantity. So if we have 1 unit and total fixed costs are 100, 100 over 1 is 100. So we put 100 over there in that cell of the table. Down here, total fixed costs are still 100 because, once again, they're fixed. Output is 2. 100 divided by 2 is going to be 50. Like I said earlier, your average fixed cost should always go down as Q rises because you're dividing the same total fixed cost, the same 100, by a larger number of units. And that matches what we expected. All right, average total cost. We have to take this total cost column and divide it by output. So don't divide by 0, so this one's a blank. 120 divided by 1 is still 120, so that goes here. 150 divided by 2 is 75. So that's where this number is coming from. So all we got to do now is fill in the marginal cost column and we're done. So marginal cost is the change in total cost. So here total cost went up from 100 to 120. That's an increase of 20. So we should put a 20 down over there. Likewise, here we go from a total cost of 120 to 150. That's an increase of 30. That means marginal costs are 30. 120 plus 30 is 150. So that completes our table and our example. So now let's go on to look at some graphs for costs. So here is the total cost for a firm, shown here in blue. TVC, that's total variable cost. I showed that in gold. Now the total costs are total fixed costs plus total variable costs. So I'm plotting both total costs and variable costs in the same graph. That means that the gap between the two must be the fixed costs. Furthermore, that gap always has to be a constant. Fixed costs do not change when you produce more. So these curves here should always be parallel, and the gap is always the total fixed costs. Total variable costs, and therefore total costs as well, should always rise as Q goes up. It should never be going down. Producing more goods is going to be always more expensive. So this graph obeys all of our rules. Costs rise as you produce more, and fixed costs are fixed, they're constant. So that works out. I said earlier that average fixed cost should always go down. That's because you're dividing a fixed number by a bigger and bigger quantity. That's going to drag down the average. So average fixed cost would look something kind of like this. So always decreasing as Q rises. So you could also graph the average total cost. We know that total costs are total fixed costs plus total variable costs. You can divide both sides of that equation by Q. When you do that, you get total cost over Q is total fixed costs over Q plus total variable costs over Q. And then you just reinterpret what each of those three terms mean. We know that total costs over Q are average total costs. Similarly, total fixed costs over Q are average fixed costs. Lastly, total variable costs over Q are average variable costs. So you can put all those on a graph. So while the total costs always rise as Q goes up, the average total costs might not always do that. So it might be the case that doubling your output might less than double your costs. So in that case, your total costs rise, but your average total costs could fall. Your cost per unit can go down even as your total costs are rising. So if you graph average total costs and you graph average variable costs, the gap between them has to be average fixed costs. So here's in blue is ATC. That should always be the highest curve among all these averages. The blue line is AFC. So the gold line is AVC. The gap between the blue line and the gold line is going to be equal to that green line. Now, because average fixed costs are always decreasing, that means the gap between these two curves here should always be narrowing. So remember, the fixed costs are going to be constant in total. Total fixed costs are constant, but you divide that constant by a bigger quantity, that's going to drag them down. So fixed costs per unit are always going down. That means the gap between those two curves had also better always be going down. Now it turns out, if you add the marginal cost curve to the story, that it's always going to cross the ATC, that is the average total cost, at the lowest point on the ATC curve. So over here, ATC bottoms out at that black dot over there. It's not a coincidence that the MC curve passes through that exact same point. Now I won't prove that to you guys in this class. The proof involves calculus, and calculus is not a prereq. If I were teaching intermediate micro, we would definitely go through the proof, and you could be assured that it's true. So for now, in principles with no calculus, you'll just have to trust me on that one. Now, to head off some possible misconceptions, you'll be thinking, is it best to produce where total costs, average total costs are minimized? The answer is don't assume that. It's not necessarily true. You don't just think about cost when you think about what's best in my firm. You also have to think about revenue. You got to try to maximize profit, not minimize cost. They're not the same thing. So it might be true you want to produce here, or it might not. You need more information. You need to know about revenue in order to make that assessment. So don't add any assumptions about this being best. They're not necessarily true. It also happens to be true that the MC curve intersects AVC, average variable costs, at the lowest point on the AVC curve. So our AVC curve here is shown in gold, and that bottoms out over here. Non-coincidentally, marginal costs pass through that exact point. The same myth is still a myth, so you're not necessarily trying to minimize average variable costs either. This point might or might not be best. Again, you have to know about revenue to make that assessment. So that's how costs work in the short run. Be sure to join us for our next episode, in which we'll learn about long run costs.